Hello and welcome back. So hopefully you are starting to get the hang of proofs of derivations in logic. So we started with what we call direct derivations. It can be a bit of a hump for students to get over. So please reach out for help if you're having trouble. Um, Reach out in the discussion board. That's what it's for, right? Don't be afraid to say, hey, how do I do this homework problem, right? It's again, the homework's not is graded on completion, and the idea is to get each other talking about it. Feel free to reach out to me, send me an email saying, can't figure out this problem. I'm stuck right here. It only takes me a second to respond and help get you, just past that wherever you're stuck on to the next thing. And of course, office hours as well. I'm a little sick, so my voice, getting over it, but my voice is a little weak. It'll be kind of a short lecture, but it would have been short anyways. So, you know, if you're not quite there with the derivations yet, it's okay. Again, I think I mentioned there's kind of two stages to understanding how to do derivations. And even if you're not 100% to the point where you feel like you can like come up with how to solve it yourself, if at least once it's solved, when you look at the homework answers and stuff like that, if you can look at each step and say, oh, okay, well, yeah, I see how that worked. Um, I just wouldn't have thought of it myself. That's fine, right? That's the first step. You'll get there with practice. So hopefully you have either pretty much mastered the derivations or like are starting to get there. We're gonna sort of kick it up a little bit a notch and add an extra kind of derivation you can do. This is it's not like a radically new kind, right? The process is still the same, but this is a new tool in your toolbox for doing derivations called conditional derivations. So they give us a way to derive conditional, right, if-then statements. So the basic strategy is, conditional statements, all they say is, if this were true, then the other thing would be true, right? Um, and so if we want to prove a conditional statement, we can actually just assume the antecedent is true and show that the consequent follows. And if we do that, we can then show that shows that the conditional is true. Um, that might feel a little abstract. We'll get into some more concrete applications of it, right? But it means we get this like put a line in our proof that just says, I'm just taking the antecedent of the conditional I want to prove for granted, right? I can pull it out of the air and put it right there. And then you have to do some work to show that the conditional follows using only the rules of inference. But if you can do that, then you can put the whole conditional as a line on the proof. So maybe as an example, if I wanted to suppose I wanted to prove that if pigs could fly, there would be pig poop everywhere, right? Um, Obviously, pigs don't fly, right? That part isn't true. The antecedent isn't true, but the conditional can still be true, right? It's about another world where pigs did fly, right? So conditional proofs, you can think of it this way. We prove it by sort of temporarily stepping into another world, a world where pigs do fly. And then we kind of look around and see, well, what is true in this world? And if it's true that there's pig poop everywhere, then we can step back into the real world. And now we can't step back into the real world and say there's poop everywhere, because there isn't in the real world. But we can step back into the real world and say, if pigs could fly, there would be poop everywhere, right? We could prove the conditional because we stepped into the world where the antecedent was true and the consequent followed. So for another example, suppose these two premises, I have if I kick a rock, I'll break my toe. I have another conditional, if I break my toe, I'll be in pain. Now, common sense tells me that, well, yeah, and if I kick a rock, I'll be in pain, right? But so far, we don't actually have a way to prove to do that proof yet, right? Because we don't have any R's on their own, to kind of like do a modus ponens or anything like that. We only have these two conditionals. We're trying to prove another conditional. So I'm going to introduce you into a way that we can prove um, that conclusion follows. Common sense says, yeah, of course. Well, here I've translated the argument. So premise one is, if I kick a rock, I'll break my toe. Premise two is, if I break my toe, I'll be in pain. And then the conclusion we want to prove is, if I kick a rock, I'll be in pain. Again, common sense says we should be able to do that. Here's how you can do that using our formal method. So here I have below that, I have the first two premises. They're the same. But look what I've done on line 3. I've shifted over. This is called a subderivation. It's a derivation within my derivation. And it says you can treat it like I'm stepping into that imaginary world. Remember, we stepped into an imaginary world where pigs fly? Here we're stepping into an imaginary world where I kick a rock, right? And so on line 3, I can just put R, and my justification is ASS assumption CD conditional derivation. When I'm trying to prove a conditional derivation, I can just assume the antecedent of the conditional I'm trying to prove. Pull it out of thin air. It doesn't have to show up on any previous premises, right? So I just get to assume R for free. Now, that doesn't mean that R can show up. I can't pull it back into the real world, right? I can't pull it out of the shifted to the right area. But within that shifted to the right area, I can use R as a premise. What would I use R for? Well, look at line 1. All my old premises in the real world, those are still fair game. I can still use those premises. So I can do 1 and 3 on modus ponens, and I can get T on line 4, right? So in line 1 was if I kick a rock, I break my toe. And on line 3, we assumed I kick a rock, right, in this imaginary world. Okay, well then the imaginary world, um, I break my toe, right? 1, 3 modus ponens. Now that we got T in our imaginary world, right, in our subderivation, we can keep going. I can use premise 2 as well, right? Again, all those premises from the real world, I can use them in my subderivation in my imaginary world, just not the other way around. So I can say 2 and 4 modus ponens, right? If I break my toe, I'm in pain. On line 4, I break my toe, therefore I'm in pain, line 5. So now I've shown that if I start with kicking a rock, I can get to I'm in pain, right? The conditional I wanted to prove. So now I can step back into the real world and see on line 6, I've shifted back, and what I've pulled back there, I can't pull R or T or P on its own back there, but I can pull the conditional, right? If R, then P. My justification there is lines 3 through 6, conditional derivations, CD. Lines 3 through 6 were the part I shifted out, right? That's how conditional derivations work. We'll try a couple more to make sure that you get it, and you'll try some on the homework as well. All right, let's try another example. So will instead of starting with the English, we'll just go straight to the symbolized argument. We have 2 premises and a conclusion. So the premises are P or Q, premise 1. Premise 2, if P, then R. And the conclusion I'm trying to prove is if not Q, then R. Well, since my conclusion is a conditional, I know that I can use a conditional derivation to prove it. Okay, apologies, I'm editing around the coughing. But so again, my conclusion is a conditional. So I know I can use a conditional derivation to prove it. And the way I start a conditional derivation is I just indent to the right on line 3, and I get to whatever the antecedent of the conditional I want to prove is, I get that for free. I can just put that on line 3 as long as it's indented so it's clear it's in my imaginary world, my subderivation. Okay, once I've got this, now my goal is to get to R, the consequent of the conditional, right? So how could I get to R from not Q? Well, again, I'm allowed to use my premises 1 and 2, and it looks like I could get P on its own with a DS, right, from line 1 and 3, and I could use that P to get R on its own with a modus ponens with 2 and 4, right? Having done those 2 lines, now I've gotten to my goal, right? I've gotten R, so now I can step back into the real world. I can't move any of these 3, 4, 5 on their own over there, but I can create a conditional now. I've proven that R follows from not Q. So I shift back to the left into the real world. I write not Q, then R. My justification is all those lines that my conditional derivation was. So lines 3 through 5, conditional derivation. All right, let's do one more example of a conditional derivation to show you that you can do conditional derivations anytime. It doesn't have to be, for example, the conclusion that you're trying to prove derivation. So anytime you think you might want a conditional, if you think it might help you solve the proof, you can do a conditional derivation. So look at this one here. Our first premise is if P then R, then S. And second premise is a disjunction, not P or R. Suppose we're trying to prove S. Well, how could we get that? Obviously, modus ponens would get us S if only we had that conditional P then R, right? We don't have it anywhere handy, but we could always try to prove it with a conditional derivation. So let's try it. On line 3, let's indent. Again, we get the antecedent for free, so we get to assume P, and we just write the justification, assumption, conditional derivation. And then how could we get to R? Well, with line 2, we can just do a ds and get R on its own. And then we're done, right? We've assumed P, we've gotten to R, so now we can step back into the real world and say, right, over on the left, if P then R, lines 3 through 4, conditional derivation, and now we have that conditional we needed in order to get S for the modus ponens, 1 and 5. So yeah, you can create, this technique can be used anywhere in any derivation, anytime you feel like you might want a conditional. Maybe it's the conclusion you're trying to prove, maybe it just would come in handy to get you something else. Um, but that's how they work, so you can use them. So practice on the homework, right? Make sure you read through the text. It's got more examples for you to work through, and reach out on the discussion boards. Reach out to me, email, office hours, and make sure you practice these. Once you get the hang of it, it's a really powerful tool.